Hello friends, welcome you all. So, in this lecture, we will see another method of minimizing DFA. So, this is Myhill Nerode Theorem, and in this, how to minimize using DFA, any DFA using this method that we will discuss here. So, first, I will show you. Uh, First, I must tell you this is a table based method, and here we create one table and then we try to minimize the DFA using this table. So, now how it is done that I will tell you. So, for this, we create one table there, and in this table, number of rows and number of columns are same. Number of rows and number of columns are same, but the number of like suppose for n number of nodes in given DFA, if we have n number of rows, then we in table we create n minus 1 number of rows and n minus 1 number of columns. N minus 1 number of columns. So here we will have n minus 1 number of rows and n minus 1 number of columns. So these are the specifications of table. Now, how to create this table that I will show you. So now here in this particular example, we have seven states. We have seven states. So in this method, what table we will use? We will make six rows and six column in the table. So now, how to create this table that I will show you. So first, these are the number of rows. So see, in both rows and column, we skip one state. We skip one state. So what we do, we can skip first state in rows and we can skip last state in columns. So our first state is 1. So we can start from our first state is 1. Initial state is 1. So we can skip it in rows. So we can start from 2, then 3, then 4, then 5, then 6, and then 7. Now, these are the number of rows. Now, we will have n minus 1 number of columns. So, as in rows, we have skipped first state. So in columns, we will skip last state here. So now our first state is 1, then we have 2, then we have 3, then we have 4, then we have 5, then 6. So we will have 6 states in columns also. Now here we have skipped last state, and in rows we have skipped first state. So now how to create this table? See. So now we can create this table like this, then like this, then like this. So this table would be of triangular shape, and this would be the last. Now, so this is our table we have created. Now we need to make cross in each block. Here we are having some blocks in this table. So we will try putting cross in each block. And at last, in which block we are not able to put cross, the combination of these two states would be merged. So now we will try putting cross in all the states. Now you can see, my friend, what would be the first criteria to put the cross. So again, as an equivalence theorem method or set method, we used first criteria as final and non-final state. So to create sets. So here we can use first criteria as final and non-final state to put cross there. So we can put cross. Cross means that particular combination of state is different. That particular combination of state is different. So we will put cross between final and non-final states. So now here we have 6 and 7 as final state. All other are non-final states. So we can have 6 cross 1, 6 and 1 cross, then 7 and 1 again we can cross, because this is non-final and both these are final. So 6 and 2 we can put cross, 7 and 2 we can put cross, then 3, 7 3, then 7 4, then 6 6 4 7 4, then 6 5 and 7 5, that we can put cross. Now 7 and 6 both are finalistic, so we will not put any cross there. Now you can see here we have three two this block is 2 and 1, so both these are non-final, so we will not put any cross. 2 and 3 and 1 we cannot put cross, 3 and 2 we will not put any cross. So only these states can only these blocks can be filled with cross. So here we have used first criteria to put cross as final and non-final state. So now we have based on first criteria we have put some cross. Now we will try to put cross in these blocks on the basis of the transitions. Now we try 2 and 1 on this block. We try 2 and 1 to put cross. So now how we can put cross here? So if 1 and 2 we are checking, or 2 or 1 we are checking. So on 1 if we are having a, so we are moving to 4, we are moving to 4, and on 2 if we are having a, so we are moving to 1. So you can check whether, see, I will now how to after first criteria how to put cross in other blocks, that we will discuss. So here how you can do it, that I will tell you. Now these cross we have already put. Now we will try filling all these blocks with cross. Now how to put cross here? So to try this, we will check the transition of A for 1 and 2. So on 1, on 1, we are if we are applying A on 1, if we are applying A, then we are moving 4. When we are moving to 4. Now on 4, on 2, if we are applying A, so we are moving to 1. On 2, if we are applying A, so we are moving to 1. Now you can check whether 1 and 4 combination have been crossed or not. So 1 and 4, we have not put any cross here. So we, on the basis of this A transition, we cannot put cross here. Now we can try with B. So on 1, if we are having B, then we are moving to 6. We are moving to 6. And on 2, if we are having B, so we are moving to 7. We are moving to 7. On 2, if we are having B, so we are moving to 7. And now check 6 and 7. Whether we have put any cross there. So 6 and 7, we have not put the cross here. So based on that, these two states cannot be uh, these two states cannot be crossed right now. Now we can try for 1 and 3. We can try for 1 and 3. So now on 1, if you are applying A, so we are moving to 4. And on 3, if you are applying A, so we are moving to on 3, if we are applying A, so we are moving to 2. So now check whether we have put cross between 2 and 4. So 2 and 4, no, we have not put. So based on the transition of A, we cannot cross that. Now on 1, if we are applying B, so we are moving to 6. And now on 3, if we are applying B, so we are moving to, on 3, if we are moving if we are applying B, so we are moving to 4. Now please check whether we have put any cross between 4 and 6. So 4 and 6 We have already put the cross. So we can put cross here. Now this new cross we have put. Now we can try putting cross in combination of 2 and 3 or 3 and 2. So now you can see on 2. Now I will try putting cross between 3 and 2. Now you can see on 2, if we are applying A, so we are moving to 1. On 2, if we are applying A, so we are moving to 1. And on 3, if we are applying A, so we are moving to 2. So let's check whether 1 and 2 are crossed or not. So 1 and 2 are not crossed yet. So we cannot, on the basis of this transition, we cannot put cross. Now on 2, if we are applying B, so we are reaching to 7. We are reaching to 7. And on 3, if we are applying B, so we are moving to 4. So let's check whether this combination has been crossed or not. So 4 and 7, this is already crossed. So here again we can put cross. Now these we have put these two cross here. Now we can try this. Now we can try this. So on 4, if we are applying now based on A transition, we can try this. Now we are trying to put cross in this block. So it is combination of 1 and 4. So now on 1, if we are applying A, so we are reaching to 4. On 4, if we are applying A, so we are reaching to 6. We are reaching to 6. That means on 4 and 6, and 4 and 6 we have already put cross. So we can cross it. So now no need to check transition of B. Now we can try other combination 4 and 2. 4 and 2. So on 2, if we are applying A, so we are moving to 1. And on 4, if we are applying A, so we are moving to 6. So between 1 and 6, between 1 and 6, we have already put cross, so we can cross this too. Now no need to check transition of B again. Now we can try this one 4 and 3. 4 and 3. So now on 3, if we are applying A, on 3, if we are applying A, so we are moving to 2. We are moving to 2. And on 4, if we are applying A, so we are moving to 6. On 4, if we are applying A, to we are moving to 6. So between 2 and 6, we have already put cross. So we can cross this also. Now we can try this 5 and 1. 5 and 1. So we can now try putting cross between 1 and 5. So now 1 and 5. So on 1, if we are applying A, so we are reaching to 4. On 5, if we are applying A, so we are reaching to 7. So between 4 and 7, we have already put cross. So this. So we can put cross here too. Now no need to check the transition of B. Now we can try 5 and 2. 5 and 2. So now on 2, if we are applying A, on 2, if we are applying A, so we are moving to 1. And on 5, if we are applying A, so we are moving to 7. So now between 1 and 7, check 1 and 7. So 1 and 7 we have already crossed. So we can put cross between these two. Now on 5 and 3 we will try putting cross. So now you can see. Now we will try putting cross between 5 and 3. So on 3, if we are applying A, so we are moving to 2. On 5, if we are applying A, so we are moving to 7. So between 2 and 7, Between 2 and 7 we have already put cross, so we can cross this also. Now we try 4 and 5. 4 and 5. Now please check. Now we try 4 and 5 combination. Now on 4, if we are applying A, so we are moving to 6. And on 5, if we are applying A, so we are moving to 7. So between 6 and 7, have we put the cross? No, this is blank. So we cannot, based on that transition, A transition, we cannot put cross here. Now let's try with B. So on 4, if we are applying B, so we are moving to 5. And on 5, if we are applying B, so we are moving to 5 again. So both between 5 and 5, we have not created even 5 and 5. So this, that means no cross is there. So we cannot, on the basis of transition of B also, we cannot put cross here. Now try this, as we have put in some new cross. So let's try this again. Now 7 and 6, 7 and 6. So we can try 7 and 6 now. So 6 and 7. Now on 6, if we are applying A, so we are reaching to 3. And on 7, if we are applying A, so we are reaching to 3. Again 3 and 3 we have not created even. So that means this is not crossed. So based on this transition, we cannot put any cross there. Now, sorry. Now we try with transition of B. So now on 6, if we are applying B, so we are staying on 6. And on 7, if we are applying B, so we are staying on 7. Now between 6 and 7, have we put the cross? So we have not put any cross. So this cannot be crossed. Now as we have put some new cross here, so we can try this again. We can try this again. So now we can try this again, and 1 and 2. Now on 1, if we are applying A, so we are reaching to 4. We are reaching to 4. And on 2, if we are applying A, so we are reaching to 1. So now see, between 4 and 1, have we put the cross? Yes, we have crossed the 4 and 1 combination. So we can put this cross here also. Now, again, 2 blocks are remaining there. So let's try it again, and then let's try this again. So on 4 and 5. Now 4 and 5 we can try for both the transition. Now on 4, if we are applying A, so we are moving to 6. We are moving to 6. And on 5, if we are applying A, so we are moving to 7. So between these two, we have not put any cross. So based on this transition, we cannot put cross here. Now 4 and 5. Now on 4, if we are applying B, so we are moving to 5. And on 5, if we are applying B, so we are staying on 5. So both are 5. So this is not crossed. So based on this also, again we are not able to cross here. Now let's try this once again. Now now 6 and 7. And see, 6 on 6, if we are applying A, so we are reaching to 3. On 7, if we are applying A, so we are again reaching to 3. So again, based on this transition, we cannot put cross here. Now on 6, if we are applying B, so we are staying on 6. And on 7, if we are applying B, so we are staying on 7 itself. Now between 6 and 7, we have not put any cross. So we have tried are so many times we are not able to fill this and this block. So we can now stop here. We can now stop here, and you can see, my friend, those blocks which are empty, the combination of states for those blocks we can merge together. So you can see which states can be merged. Here we have 4 and 5, and here we have 7 and 6. So state number 4 and 5 and 6 and 7 both will be merged for minimizing this particular DFA. And if we merge these four states into, so in resultant DFA, only 5 states would be there. Now you can see, my friend, if you refer the last video of this playlist, you could see we have used equivalence theorem or set method to minimize the same DFA, and in there, using that method also, we are having only uh, five states in resultant DFA. So he they are also 4 and 5 we were merging, and 6 and 7 we were merging. So the same answer we have got through this Myhill Nerode theorem. So this is how you can apply Myhill Nerode theorem on any DFA to minimize it. And I hope, friend, it would be very much clear. Now, if you have any doubt, you can always write to me in comments. I will definitely reply your comments. Thank you. Thank you so much.